Hi and welcome to another tutorial in Unity 5 from Scratch series. Today we're going to look at physics, which I would consider to be the most fun you can have in the game engine without actually coding. So to begin with, we're going to create a cube and a ground plane. I've already added two materials, as you can see here. So this is a new Unity project. So I'm going to create a 3D object cube. And I'll make that red by putting the red material onto it. I'm also going to create a ground, which will just be another cube. 3D object cube. Just lower that down. I'm going to color that blue. And I will resize it to make it quite a large ground plane. I shouldn't call it a ground plane because it's not a plane, it's still a cube. But you get the idea. Right, so if we just move the scene around a bit, we've got this cube, which I'm going to lift up. And we've got a ground for it to essentially fall on once we turn on gravity. Now, so we can see all of this in action, you need to have your game scene dragged out and put it next to the scene window, so we can see both of these at the same time, which is useful when we start to run. Okay, now I've done what I did in the last tutorial, which was accidentally attach my ground to my cube, so let's just move that out of there. Let's call this ground up in the hierarchy so that it makes more sense for us. And the cube is now separate. Alright, so here we have this scene and the game. Now we're going to add some physics to our cube. Now at this point, if you press play, so this is the first time in the series we've actually pressed play, the play button starts to run the code and run the physics system. We're in play and you can see nothing's happening because there's no code and there's no physics in the scene. The physics will actually run independently of having any code, so that it means we can actually see something happening and things will start to move around. Let's just stop playing. One important thing about this play button is if you make any changes while you've got play going on, they will all revert back after you turn play off. So if you want to make changes, please be sure that you've turned play off. Right, so let's add some physics to this. Okay, with the cube selected, we're going to go add component, physics, and we're going to add a rigid body. The rigid body is the component that does all of the work in the physics system. And you can see here that it has given our cube a mass, it has a drag value, has an angular drag value. We can then set it to use gravity, which is by default turned on. And then we have a few other settings that we'll talk about in a moment. So just with the default rigid body on, let's press play. And the cube falls and it hits the ground. Okay, why does it hit that ground? If we select ground, whenever you add a basic shape into Unity, it comes with what's known as a collider. And you can see that the ground has this box collider added to it automatically. And the cube itself also has a collider added. Let's just go back to the ground. When the collider is added, it allows the ground to be put into the physics system so that it can be collided against. So it makes it essentially a solid object. So the rigid body of our cube when it falls, when we press play, is that it will hit the ground. If I select the ground and I turn off its box collider, I'll leave it there but just untick it, press play again, the cube's going to fall straight through the ground because it's as if the ground is not there. It's not in the physics system. So it's not regarded as anything solid, I guess. So let's just turn that back on. Okay, now if we were to turn off gravity on the cube, you can imagine what's going to happen. So if I turn off use gravity, press play, nothing's going to happen because there's nothing being added to that cube. There's no force being added to that cube. You might be wondering, where does this gravity come from? Since it's a force and we can turn it on and off, can we also control it? And the answer is yes, you can control it. If you select Edit from the main menu, Project Settings, and then Physics, you can modify the gravity. You'll also notice as we go through this, there's an option for 2D physics. These work in the same way as 3D physics, but they're for 2D games. And we won't look at them in this actual tutorial, but they do have the same colliders and rigid bodies that you can attach to objects. Let's just select that physics. Then over in the inspector, you will see the properties for the physics system. And in this case, our gravity is set to minus 9.81 in the y direction, and 9.81 meters per second is the gravitational acceleration on Earth. So that your object in the game is going to fall at 9.81 meters per second squared as you press play. If you're familiar with physics, high school physics, you will remember this 9.81 value. If I were to change physics to be 9.81 from the negative to the positive and then run our game, our cube should go upwards, which it does at 9.81 meters per second squared. Okay, so that's the physics system. If you wanted to change physics to be in the x direction, so let's just get rid of that there, change it to be, let's just say 5 and run it. The cube is now going to fall in the x direction. And you can do that with the z as well. I'm just going to set this back to the default 9.81 there. All right, so that is the gravity, and we'll come back and look at some of these properties a little bit later. Let's just select our cube. What if we want the cube to say bounce when it hits that ground? We can add to the physics system a material. So we can set the properties of that cube to be like a bouncy object. If you have a look in the collider component for the cube, there's a section for material. And that's where you add in your physics material. To create a physics material, we do that in the project, create, and then down to physics material. Again, you'll see that there's a 2D physics material, which is going to work the same for a 2D game. Let's create physics material and call it bounce or bouncy. And we're going to use bouncy as our physics material for our cube. So if we select the cube, we can then drag and drop bouncy from the project and drop it in to this physics material here. Now, this is the default bouncy. And if we select the material in the project and then look at its properties in the inspector, you can see that it currently has no bounciness. So we can turn that bounciness right up to 1. It goes between 0 and 1. And then we can press play. And you'll see that some bounce has been added to your cube. You can also modify how the bounce occurs using this bounce combine value here. And if we just drop down this box, you can have a look at the different options. So we've got an average, a minimum, a multiply, and a maximum. And these are the ways that the bounce is combined between one object and another. So in this case, it's how the bounce value is combined between the cube's bounce and the ground's bounce. Okay, so the ground has no bounce whatsoever because it doesn't have a physics material on it. So we could just say that it's 0. So what happens is each time it bounces, it's averaged in this case. Okay, so it might start out at bounciness of 1, then it hits 0. So that will then average the 1 and the 0, which would give you like 0.5. So the next time the bounce isn't going to be as great, and then it's going to halve it again and again. So we can see that when we press play because the cube essentially is losing the energy and it's bouncing like a normal object would, where it's not going to keep bouncing. If we have a look at those other settings, let's go back to my physics material. Okay, for combine, you can also do a minimum. Now, the minimum, and this is now going to show you exactly what I mean if I don't have play turned off when I make a change. Oh, I did keep it. Okay, that's good. So we're going to set this to minimum, then we play it. What will happen is that the bounce will be based on the object with the minimum amount of bounce, which is the ground. And the ground has no bounce, so when we run this, there will be no bounce. Okay, let's now set this to multiply. Multiply will multiply, obviously, the bounce of the cube with the bounce of the ground. The ground, again, has no bounce, so our 1 multiplied by 0 is going to give us 0, so we should just expect that we will have no bounce. Again, there's no bounce. And then we have a maximum. Now, the maximum takes the object that has the maximum bounce. And this is quite interesting in that when we run this, the cube will actually start to gain energy. And as you can see, it'll start to bounce and eventually it will just bounce off the screen. So in this case, it's like the cube is a trampoliner and putting more effort each time bounces and gets higher and higher. Okay, so that's bounce. The next section of the physics materials is the friction component. So friction is how much an object will stick to another object or slide on another object. So to demonstrate this, I'm going to grab the ground plane and rotate it to make a bit of a ramp. Let's just check which way I'm... Okay, let's do it this way. And let's just have a look at what we're going to get. Okay, let's just play that as it is and see what happens. Yep. And I'll might just adjust the camera a bit. So we get a better view of what's happening. Okay, so there's the cube bouncing down. And let's turn the bounce of the cube off. So we go to this bouncy physics material and we will turn that off because we don't want to sort of, I guess, confuse matters. Okay, so with the bounciness turned off, this cube should just roll down there. Okay, no friction whatsoever. So let's turn the friction of the material on the cube up, which is our bouncy, okay, but that bouncy 0. Let's turn up our dynamic friction. So dynamic friction is the friction that gets applied when your object is moving. I'm going to turn that up to, let's see if we can get it as high as it'll go. Actually, I'm not sure what the maximum of this is. Let's put in 100. Okay, that will do. And then we run that. And you can see that it's slowed down a fair bit. Because of the slope, it's going to hit and already be in a rolling mode. So if we just grab this cube and rotate it a little bit so it kind of lands on its base, And we'll also make the base bigger so that it has more surface area that's contacting the ground when it lands. Now if we press play, let me just check that physics material. Still got 100 in it. Okay, and run it. Still grabbing hold. I'm very determined to get this to hit and stick. Whoop, wrong axis. Stick on the ground. Oh, very close. No, once it starts rolling, we've lost it completely. Okay. Right, let's continue anyway. So that is the friction component set up quite high for dynamic. Now, the static friction is friction that's added when the object is actually stationary. So you can also put that in there as well. So if an object has come to rest, then it can grab, really hold on hard onto the surface. In the material, there's also a friction combine value that works in the same way as we went through with bounciness. The way that the friction combines, though, is a little bit confusing when you're dealing with an object that does have friction and an object that has no physics material whatsoever. So we've had it so far set on average. If we went to maximum, it's going to use the cube's dynamic friction itself. So which is what we were working with before. So we will get the same result where it's trying to stay still, but then gravity just takes over. With the minimum, it's quite interesting. It's going to select the minimum, which is the friction of the ground. Now, the friction of the ground, it has no friction. So that is different from saying that it has zero friction. Zero friction would be like ice, so extremely slippery. But we haven't set any friction on the ground. So it's kind of got no friction in a way, which means that you get an interesting effect that you wouldn't expect. If we run it with minimum friction, the cube actually sticks to the ground. It's kind of like the physics system says, oh, well, you've got no friction on the ground, therefore I'm not going to calculate any friction and I'm not going to do it for you. And so it stops, which gives us the effect that we were trying to get just before. Okay, just before I end this tutorial, we should look at setting the friction to 0 and what happens in that case. So a friction value of 0 is such as ice. So you can think of a value of 0 as being ice on ice, and a high, or the highest friction value you can set at, is like concrete, rubber on concrete, which is the most grip. Now, if we set it to 0 and go back to our average and we press play, you'll now see that our cube will act as though it's made of ice, and it will just slip down the surface there. Okay, so that is the physics material and the settings that you can put in that. In the next tutorial, we'll continue looking at physics and we'll have a look at the rigid body's mass and drag values.